Welcome to the Project Lead the Way instructional resource on program planning. As you begin to explore programming, it's important to think about robot actions in terms of behaviors. To aid in the program planning process, it is helpful to categorize behaviors into three groups: basic, simple, and complex. A basic behavior of moving forward could simply consist of a single motor turning on for a set amount of time. A simple behavior combines multiple basic behaviors, such as moving a robot forward a set distance. Complex behaviors are made up of simple behaviors and could include solving a maze or sorting materials where multiple motors might be used for navigation purposes, while sensor data is used to make navigation decisions. Let's apply the behavior approach to programming to a simple maze challenge. In the challenge, a robot will start in the red start zone and must navigate to the blue goal zone. All navigation in this example will be programmed. Let's begin by visually representing our three categories of behaviors. The complex behavior for this challenge can be defined as moving from the start zone to the finish zone. The complex behavior is represented using a continuous blue line. The line is continuous because it's one single complex behavior. The simple behaviors that make up the complex behavior would include move forward, turn left, move forward, turn right, move forward, turn right, and move forward. We will represent the simple behaviors using green line segments. Each simple behavior is made up of basic behaviors such as turning on two motors or waiting an amount of time.
All right, so what you're going to do, we're going to look at those behaviors. You're going to do Robot C and or explore VEX VR. So let's just look at this PowerPoint just real quick. We talked about the behaviors, complex, simple. So we'll start with simple tasks, and then you'll get to have some fun and make your own complex examples would be a vending machine, some video games, things like that. So here are some examples of complex behaviors. When you do these, there is something random that they just put out, this fancy word pseudocode. The computer is going to talk to the robot, and that is going to be programming language. Pseudocode is going to be the language for me and you. For example, turn a motor on for 3 seconds. That's going to look a lot different in VEX VR or Robot C. Again, simple behaviors are just turning on a motor, turning on a switch. Analog and digital, we're going to get to know the difference. Digital would be 1 and 0, turning on or off. Analog would be variable, like your speaker, turning it up or down. Pseudocode examples are here. Again, the language for me and you to understand. Some basic behaviors are just inputs and outputs relative to the device. Here are some examples. LED 1 on for 3 seconds, fan until the button is pushed. These are just, again, examples of pseudocode that you can read on your own. Inputs and outputs, what are we putting into the system and what are you putting out? We will have lots of sensors, like I said, digital are on and off, 1 and 0. Analog are variable, that can be lots of different numbers. And your Cortex has those little ports that you're going to have to look at. We will be using the Robot C template that you can load. Everything in green is the pseudocode. It's very important that you tell the robot what is happening in the blue and the red, but the green is for me and you. Telling the task, who you are, and what actually the program's going to do. We'll talk about the debugger window and the motors and sensor setup. That's the very first thing that you're going to do in Robot C. Set everything up so that the computer can communicate with the robot or the Cortex. This example would be the pseudocode is start motor at half power. You're going to learn about the motors have different powers, and then waiting 5 seconds so it'll run, and then stopping the motor. In blue and red is going to be your programming language that you're going to learn about. Task main will define what the robot is going to read within those brackets. Don't get frustrated with the parentheses and brackets. Ask me or another set of eyes to look at that, but sometimes when you get red X's or yellows, it yells at you. It won't like things. That's okay. It's something that you'll learn about. This Pragma file up at the top is the motors and sensor setup. Please do not touch that. That will mess everything up if you do. But everything in the task main, those curly braces in between, is what the robot will be. Again, the motor will start at half speed for 5 seconds and stop. We will start out with basic behaviors and go to complex. Here is another simple program. An LED turns on. LED 1 is the name. It waits 3 seconds and then the LED turns off. Another example of a fan motor, Intel bump. Again, I just want you to understand that the green is between me and you, the pseudocode, and the blue and the red is what the robot will actually understand, the coding. Everything in the brackets, the task main, is what the robot will read. Let's see, some of this is a little, don't forget, Robot C has a lot of samples. You are free to take a look. The one that we want is the PLTW template in the PLTW. Don't go to VexIQ. I believe it's the folder Vex2. And it is natural language that your robot is reading. So again, robot platform type is the Cortex, Vex 2.0, and natural language. If you're doing it remotely, you're going to get your compiler target a little different, and that will be a virtual world robot, but this is for the physical robot. These are all the command motions on the left, the menu. Again, the different movements, set motor, start motor, set servo, stop motor, we'll start out with. We're not going to worry about reversing it. We can just do negative to do that. Flashlight, I don't like that turn flashlight on or off. Sometimes it works, sometimes it doesn't. I always just say it's start motor. I look at the port and it's in a motor port. Something for later. Until bump, until dark, things like that, you'll be doing that. Waiting commands, there's lots of different commands. Sensors, again, digital will be 1 or 0. And we'll have, I think, 3 different types. And then you'll also do the analogs. In the Vex VR, okay, in the Vex VR, you will get all your sensors and all your programming here. It looks way different than the natural language. It's more of the block. This is also with the new V5s that we have when we get in the classroom. So again, all your commands are going to be different. The gray for the Vex VR is going to be your pseudocode. You're still going to need all your pseudocode. And then instead of the physical robot, you're going to have the playground, it's called. Okay. You're also going to be watching an Edpuzzle about Robot C and natural language. So whatever you choose starting Wednesday, I just want everybody to understand that there are different options. Either the Vex VR, the virtual robot, the Robot C. You can do either the virtual robot or the physical robot. If you're not here at school, then you can do the PC-based emulator, which simulates the physical robot. You can just watch the commands. So go to the Edpuzzle for Robot C, and then you're done for the day. That will be on Schoology, the Robot C introduction. Have fun too. That's really important.